Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from current electricity concept. Okay. The only thing that I expect from you is a single like. Okay. Now let us go to our first question. What is our first question? 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. The ratio of power consumed by the bulbs when all are glowing, that is first case. Second case is in the situation when 2 from section A and 1 from section B are glowing. Okay, now let us see what he asked. He said that he has 6 similar bulbs which are connected to DC power supply of EMF E and 0 internal resistance. Okay, so these are 6 similar bulbs which are connected to a DC power supply of EMF E and internal resistance 0. Now what he is asking us to calculate? He is asking us to calculate the ratio of power consumed. That means he is asking us to calculate the ratio of power consumed. P1 by P2 is equal to how much? In 2 cases. The first case is the case where all are glowing. That is, all 6 bulbs are glowing. The second case where 2 from section A, let me take these 2 from section A are glowing and 1 from section B is glowing. Okay, that means rest 3 are not glowing. Okay, now in these 2 cases you have to calculate the ratio of power consumed. Okay, now first let me say what do you mean by similar bulbs. Similar bulbs are the bulbs, these are the bulbs where their power rating and voltage rating will be same, that is constant. Since the power rating and voltage rating are constant, that means their resistance value will be constant. That is, the value of resistance of these 6 bulbs are same. Okay, that's first point. The next point is these bulbs are resistive elements. That means for our convenience, we can replace these bulbs with resistors whose value is equal to their internal resistance. Okay, now if I apply this logic, what will happen? This circuit will get converted in like this, where you have 2 sections, section A, section B. In section A you have 3 resistors, that is 3 bulbs. In section B you have 3 resistors, that is 3 bulbs. These 6 resistors are connected to a source of EMF E and internal resistance 0 internal resistance. Okay, now let us go to our first case where all bulbs are glowing. That means all these 6 resistors are effective. Okay, it is clear that, okay, and I took the value of internal resistance as R. That means their resistance values will be R. All 6 resistors resistance value will be R. Okay, now if you see that now in first case all the 6 bulbs are effective. Okay, so if you see in section A, it is clear that these 3 resistors are in parallel. Then their effective resistance will be R by 3. Okay, if you use the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, similarly in section B, these 3 resistors are again in parallel. Then their effective resistance will be R by 3. Okay, now let me redraw this circuit. What will happen? If I redraw this circuit, what will happen? I have a source of EMF E and internal resistance 0, and this source is connected to a resistor whose effective resistance is R by 3, and it is again connected to one more resistor whose effective resistance is R by 3. Okay, the point here you have to notice the effective resistance in section A, the effective resistance in section A will be in series with the effective resistance in section B. That is why I do these 2 in series. Okay, since these 2 are in series, then the effective resistance will be 2R by 3. If I use the formula R is equal to R1 plus R2. Okay, now let us go to case 2 where 2 from section A are glowing and 1 from section B is glowing. That is, these 2 are glowing in section A and only this is glowing in section B. Then what will happen? This resistor will be ineffective. Similarly, this resistor will be ineffective. Okay, now what happens? Now these two are in parallel. Then what will be its effective resistance? Its effective resistance will be R by 2. And that is in series with this other resistance in section B. Okay, now let me redraw this circuit. Okay, if I redraw this circuit, what will happen? I have a source of EMF E whose internal resistance is 0, and this is connected to a resistor whose effective resistance is R by 2, and this resistor is connected in series with one more resistor whose resistance is R. Okay, now these two are connected in series. When these two are connected in series, the effective resistance will be 3R by 2. Okay, the effective resistance will be 3R by 2 since these two are connected in series. Now let us go to our question. What did he ask us to calculate? He asked us to calculate the ratio of powers. We know the formula for power as P is equal to V square by R, where in this case it will be E square by R effective. Okay, E square by R effective. E is constant in both cases. That means I can write like this. That is P proportional to 1 by R effective, which is nothing but R. If I apply this logic, I'll get like this. The ratio of power consumed P1 by P2 will be equal to R2 by R1. Okay, that is equal to R2 is this resistance while effective resistance, R1 is this effective resistance. If I use these values, what will I get? The ratio of power consumed will be equal to 3R by 2 whole divided by 2 small r by 3. Sorry, this is small r. 2 small r by 3. This small r will get cancelled. Similar, this is also small r. Okay, then what will I get? I'll get 3, 2, 4, 9:4. So the ratio of power consumed in both, the ratio of power consumed will be 9:4, which is option 2 in our question. Now let us go to our next question. Our next question is, which of the following acts as circuit protect device? Okay, now first, what do you mean by circuit protect device? It is a device which protects the circuit from excessive current. Okay, now see, if you see the options, conductor has it won't act as a circuit protective device. The reason is, so in the case of conductor, if excess current flows, what will happen? These conductors have high melting point. Okay, since they have high melting point, what will happen? Though excess current flows, this conductor will not melt. That means there won't be any break in the circuit. So if there is no any break in the circuit, what will happen? The circuit will get damaged if excess current flows through the conductor. Okay, the same is the case of inductor. Now if you go to switch, it is manually operated. Now let us go to this fuse. Fuse is a what you call a conductor. Fuse is a wire which is generally made up of combination of tin and lead, and it has a low resistivity and low melting point. Okay, since it has low melting point, what will happen? If excess current flows through this fuse, what will happen is heat will be generated, and because of this low melting point, that wire will get melted. When the wire get melts, what will happen? The circuit will break. Since the circuit is break, it protects the device. Okay, so fuse is the device which is used as a circuit. Fuse is the element which is used as a circuit protecting device. Okay, now let us go to our next question. Our next question is, in the circuit shown below, the readings of voltmeter and ammeter will be. Okay, so now what did he say? He said that you have two circuits. Okay, this is circuit 1 and this is circuit 2. Now what he is asking us to calculate? He is asking us to calculate the relation between V1, V2 and I1, I2. Okay, he is asking us to calculate the relation between these two. Okay, so observe this. This is circuit 1. This is circuit 2. Okay, so before going to this solution, let me say two important points that are useful to solve this sum. Okay, now how will you get voltmeter? We'll get voltmeter by connecting high resistance in series with a galvanometer. Okay, so since we connect high resistance in series with galvanometer, what will happen? The value of resistance of voltmeter will be very high. That means in ideal case, I can take the value of resistance of voltmeter as infinity. Okay, that is first point. Next point is, how will you get ammeter? We will get ammeter by connecting a small resistance in parallel to galvanometer. Okay, since we are connecting small resistance in parallel with galvanometer, what will happen to its effective resistance? Its effective resistance will be very less. That means in ideal case, I can take the value of effective resistance as 0. That means the effective resistance of ammeter will be 0, or the resistance offered by ammeter in the circuit will be 0. Okay, so these 2 points are important to solve this sum. Okay, now let us go to first part. So here you have a resistor of resistance 10 ohm, a DC power supply of voltage 10 volts. Now here you have ammeter. In ideal case, we can take its internal resistance as 0. That means this is short. Okay, and here you have voltmeter, and in ideal case I can take its resistance as infinity. That is, this is open. Okay, that is, this is open, R equal to infinity. Now let us try to calculate the value of I1. So this is open, then what will happen? This entire 10 volts will drop across this 10 ohm resistance. Okay, now if I use the formula, if I use Ohm's law, what will I get? I1 is equal to V1 by R. That is equal to 10 volts by 10 ohm. That is equal to 1 ampere. Okay, so 1 ampere current flows through the circuit. Okay, then you have to calculate V1. What is V1? V1 is nothing but the potential developed across this resistor. That is equal to I1 into R. I1 is 1 ampere into resistance is 10. That is equal to 10 volts. Okay, so these are the values of current and voltage in first circuit. Now let us go to our second circuit, where you have 2 resistors of 10 ohm each, and voltmeter and ammeter, and this combination is connected to a battery of potential 10 volts. Okay, now since the resistance offered by this is high, that is infinity, what will happen? I can assume this as an open circuit. Then what will happen? The entire current generated by the power supply will pass through this 10 ohm resistance only. Okay, now let us calculate I2. Okay, according to Ohm's law, I2 will be V2 by R. V2 by R. Okay, V2 will be 10 by R will be only 10. It won't be 10 plus 10 in parallel. Okay, it's only 10. That is 1 ampere. Okay, then now what is V2? V2 is the potential developed across 10 ohm resistance. Its formula will be V2 is equal to I2 into R, the top 10 ohm resistance. V2 will be I2 into R, that is equal to 1 into 10, that is equal to 10 volts. So if you observe, the value of I1 in first case and I2 is in second case is same, that is 1 ampere, and the value of voltages are also same, that is 10 volts. So both currents will be same and both voltages will be same. That is option 3 in our third sum. Okay, now let us go to our fourth sum. Our fourth sum is, the color code of a resistance is given below. The value of resistance and tolerance are. Okay, so now this is a resistor. This is a resistor whose color codes are given. Now what is he asking us to calculate? He is asking us to calculate the value of resistance of this resistor and its tolerance value. Resistance is how much and its tolerance value. Okay, so if you observe, the color of first band is yellow. That means your first digit of your resistance value will be 4. Okay, then the color of second band is violet. That is your second digit value of your resistance will be violet, that is 7. Okay, then the color of third band is brown. That is your tolerance value will be brown, that is 10. Sorry, your multiplier will be 10. And the color of third band is gold. That is your gold. That is your tolerance will be 5%. Okay, this if I arrange, it will be like this: 470 ohm plus or minus 5%. That is option B, where the resistance of this resistor is 470 ohm and it gives a tolerance of 5%. If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe because your single like and comment will encourage me for making better videos. Thank you.